Section 7.9, Precision and Significant Digits. Okay, if we talk about precision of a measurement, what we're talking about is how the device that you're using, like a ruler or a graduated cylinder or a scale, how precise that is, how many markings it has on it, how many places after the decimal you can get. And a lot of times we call that the precision unit. So if we look at this ruler right here, you can see that it's measured in quarter of an inch. There's a quarter of an inch, half inch, 3/4, and so on. So the precision unit of that ruler is 1/4 inch. Now, on this flask here, you can't see this very well, so let me kind of write it out a little bit. Let's say that there's a 50, and then there's 100, but in between there's another mark, is what they're trying to tell you should be there. So what we're going by, this would be 25. Can't read my writing here very well. This one here would be 75. So our precision unit on that, it goes by 25. So that's the precision unit that we would have on that particular one. Okay, you try these. Look at the ruler, look at the stopwatch, and tell me what the precision unit is of each one of those. Okay, so for this one, the numbers are centimeters. That means there's marks in between of those. Those would be millimeters. So the precision unit on this is either 1 millimeter or 0.1 centimeters, depending on which way you want to say that. If we look at the stopwatch, you can see that it goes to the nearest hundredth, and we're in seconds, so our precision unit would be 1/100th of a second for that. Alright, let's go down and look a little bit down here just a bit. We talk about one way that we can record these measurements using precision is with something we call significant digits. And significant digits are the measurement that we have, the ability of the scale, plus one more place, one estimated digit. See, we can use the precision units that are on the device, but we can always estimate it one more place beyond that, and that is a better measurement. And when we do that in science, we do this a lot in chemistry, physics, and stuff, then we call that significant digits. So let's take a look at this example here. You can see that when we're looking at the pencil on my ruler here, my precision unit is the centimeter. So, I could read it and I could say, oh, that's 14 centimeters, but I can actually estimate better because you can see that, it doesn't go exactly to 14. So it'd be better if I estimate. Now that last estimate is a guess. So there's going to be some error there. So we want to understand it, and that's what the idea of significant digits takes into account. So my precision unit is a centimeter. It's somewhere between 14 and 15. In my estimated measurement, I'm going to say that's 14.3. Now look over here where we have a ruler that's marked to the nearest tenth of a centimeter, and we can measure that a little bit better. We know that I can see it somewhere, it's hard to tell with my mark here, but it's somewhere between 14.3 and 14.4, and I'm going to just estimate that that's going to be at 14.35. So those first three digits are how accurate my ruler can measure, and then that last one is an estimate. And so I get from that I get 4 significant digits on that particular one. So my precision unit is a tenth of a centimeter. The actual is somewhere between 14.3 and 14.4, and I'm going to estimate it to be 14.35. Now let's say that somebody has already estimated these or done this measurement for you, and you want to figure out the number of significant digits that are there. there are several rules here for finding significant digits. There's one rule for all of the numbers from 1 to 9, and that rule says that anything that's not a 0, any digit 1 through 9, is significant. So in my first example, 2.45, it has 3 significant digits because all of those are numbers from 1 to 0, or 1 to 9. Every other rule we have, these other 4 rules, all deal with 0. So 0 is kind of our tricky one when it comes to significant digits. So if we take a look at this second one, this rule says that zeros between 2 significant digits are significant. So, you know, if I have my 140.06, well, the 1 and the 4, we know those are. We know the 6 is, and everything in between always is. So that's the case. If the first and the last are, everything in between is. Or any time that we know 2 significant digits, anything in between those 2 is always significant. Well, let's say that it's not in between. What if it comes in the front? And what if you have the number like 0.013? And they say that they call those ones, these zeros are here to hold place. In other words, obviously if I dropped those zeros and I had just 0.13, that's a different value than 0.013. So zeros that hold place are not significant. Or a lot of times I call those preceding zeros. Ones that come in front. Those are not significant. Okay, let's take a look at this next one. How about ones that come at the end? So here we've got some zeros at the end of the number. Well, if those zeros come at the end and they're after the decimal, then they're significant. So I call them trailing zeros. If a trailing zero comes after the decimal point, it is significant. Now the decimal point is the key part of this. So the fact that the decimal point is in there and 0 comes after it, we wouldn't put it in there if we hadn't measured it that accurately. So therefore it is significant. And let's take a look at the last one. Now notice that there's no decimal point. So if there's no decimal point, we've got trailing zeros, ones that come at the end, no decimal point. Once again, these are placeholders. Obviously the number is different if it's 35 versus 350. So, but because it comes before the decimal point, then they are not significant. Okay, so that one only has 2 significant digits. All right, you guys try. Or actually, let's look at these first. So if we look at this one, 10.25. Well, the 0 is the only one we really have to worry about, and since it's between 2 other significant digits, it is significant. And if we look at 0.003, well, those are preceding zeros. Zeros that come at the beginning are never significant. So those zeros are not, they're just simply placeholders, so we only have 1 significant digit in that example there. All right, what if you have to add them? Let's take a look at this example in addition. We've got these 3 packages that we weigh, and we're going to add them together. And so we've got, should clear all that. We've got 6.75, 5.125, and 4.6. What's important when you're adding or subtracting is the least precise measurement that you have. So for instance, if we look at this one, we measured that pretty good. We did 2 places after the decimal. The next one, oh man, we did that one really well, 3 places after the decimal. But this last one, we didn't do very well. We don't have anything, you know, in the hundredths place or in the thousandths place. So we only measured it to the nearest tenth. So we just kind of dropped all that precision there at the end, and that kind of makes an error for everything. So when I get an answer, now I would add that together and get this on the calculator, but because I have one that only has 1 place after the decimal for my significant, you know, or my precision measurement, my answer can only go 1 place after the decimal. So I've got to round this off. So I need to round it off to 1 place after the decimal, in other words, to the nearest tenth. And if I do that, I would get 16.5 pounds. And that's the rule for when you're adding or subtracting. It goes by where those are located. You go to the one that has the least precise measurement, and whatever decimal place that is in, that's where your answer is going to also be rounded off to. If we're multiplying, the rules are a little bit different for multiplying or dividing. It's a little easier, I think, actually. And when we multiply or divide, what we're going to do is use the correct number of significant digits in the measurement that has the least amount of those. In other words, if I look at this answer, 10.4, has 3 significant digits. 6.2 has 2 significant digits. That means, since there's 2 is smaller than 3, obviously, my answer has to only have 2. So the measurement has the least number of significant digits, or the answer has the same number as the least number of significant digits. So if I multiply that out and I get 64.48, that's 4 significant digits, but I have to only have an answer with 2. So I'm going to round it off to 2 significant digits. In this case, it's going to be the 10s and the 1s. So I'm going to round it off to 64. All right, these are a little tricky. Why don't you guys give those a try? We'll come back and take a look. All right, in that first example, you're going to get 3.48 minus 0.2. So the first answer goes to the nearest, or goes to the hundredths place. The second one only goes to the tenths place. If I just do it on a calculator, I get 3.28, but I've got to round it off to the nearest tenths place, so my answer would be 3.3 in that example. Okay, if we take a look at the second one here, we've got 0.45 divided by 0.8. And if I put that in on my calculator, 0.45 divided by 0.8, I get, the answer I get on the calculator is 0.5625. Looks like 4 significant digits, but if I look at my answers, or my original, not the answers, but my numbers that I measured, I've got 0.45, which has 2, and 0.8, which only has 1. Therefore, my answer can only have 1 significant digit. So I need to round it off, looks like to the nearest tenth. So I would get 0.6 for the answer. All right, kind of tricky ideas. I think we just need with this especially a little bit more work. So would you go down and down here in the sample problems in your book, let's clear that, would you do these, let's do, I think we need to do all of these. So let's do 6 through 13. Write those down, show me those in your notes, and we'll double check those just so I make sure you understand. This is not a simple idea. You know, we do this in chemistry and physics, and those guys find it difficult to do. And so if juniors and seniors find it difficult, it's going to be a little bit more difficult concept even for 8th graders. So spend some time thinking about this. It takes a little bit of work.